Okay, for these problems, we're talking about properties of isosceles triangles. Base angles are congruent, or angles opposite congruent sides are congruent. If you have congruent angles, then the sides opposite those angles are congruent. It takes at least two congruent sides to be isosceles. Equilateral triangles are also isosceles. They just have three congruent sides. So you'll see this diagram a lot, talking about the base angles. If you have congruent sides, the angles opposite those sides have to be congruent. So that lets us know that that's a 58-degree angle, and 258 subtracted from 180 lets us figure out what angle T measures. So angle T is going to be 64 degrees. Looking at number 2, you've got an isosceles right triangle. Each one of those base angles has to be 45 degrees because two angles equal make 90. And again, the angles opposite the congruent sides, A and G, have to be congruent because those sides are congruent. They're complementary, they are equal, they both have to be 45 degrees. Okay, let's look at number 3. Number 3 is an exterior angle problem. You got the two congruent sides, those are going to set up congruent angles. And basically you're going to have two congruent angles equal to 110, which is going to let us know that each one of those has to be 55 degrees. And then a linear pair with x and the 55 lets us know that x has to be 125 degrees. So I'm mainly just doing these, looking at solving the diagram and then answering the question. So those two remote interior angles are congruent because of the isosceles triangle, and they also have to equal 110 degrees. So that gives us 55 degrees for each one of those. And x is going to be the linear pair. So it's going to be 125 degrees, not 25 degrees. For number 4, we need to find the perimeter. The triangle is isosceles, so A is also equal to 13. Those are the two congruent sides, which lets us know that the other side, which is 13 plus 7, is going to be 20, or have a length of 20. So side AC has a length of 20. So the total perimeter is going to be 13 plus 13 plus 20, which is going to be 46. And we pretty much have, okay, I think we pretty much have the rest of it then. But again, focus on solving the diagram. If we look at 5 here, the perimeter is the sum of all the sides plus LM. If we subtract the sides that they give us from 536, we end up with the length of LM is equal to 163, which makes it a congruent triangle. So LO and LM are going to be the two congruent sides. They're both going to be 163. That lets us know that the angle at O and M are both going to be congruent, which means that the measure of angle M is equal to X, because they're base angles opposite the congruent sides. And since they all have to add up to 180 degrees, we can calculate that angle X must measure 50, since X is equal to 50. Okay, looking at number 6, they're giving us the perimeter. It's isosceles, so side QS is also y plus 31. So we have y plus 31 plus y plus 31 plus y is equal to the perimeter. So we can figure out what y is from that. To find the measure of angle Q, since it's isosceles, we have two 68-degree base angles, and we can figure out that the measure of angle Q is 44 degrees. So again, we're solving the diagram and then filling in the blanks. So to find out the actual length of QR, we have to solve for y. When we get it all together and subtract from 344, find that y is equal to 280. 3y is equal to 282, so y is going to be 94. Now if y is 94, the length of QR is going to be 94 plus 31, which gives us 125 centimeters. Okay. Going on to number 7, they give us a pair of parallel lines and a transversal. So alternate interior angles are going to be congruent. The best way to do a problem like this is just to mark on the diagram the congruent angles based on the relationships. So angle ADB is going to be congruent with angle CBD because those are alternate interior angles. What we're doing right here is kind of doing a little cheat notes thing on parallel lines with transversals. If you have parallel lines cut by a transversal, alternate interior angles are congruent. Those are opposite side, inside. Corresponding angles are congruent. Same side, and same side interior angles are going to be supplementary. We'll mark those. So over on the diagram, we're looking at parallel lines cut by a transversal. That gives us two pairs of congruent angles. Then, if we look at the two triangles as being isosceles, AD and BED are marked as congruent, and DB and also BC are marked as congruent. Those gives us all congruent base angle pairs. So we're going to mark those in blue. So in the upper triangle, again, the opposite angles are going to be congruent because of the congruent sides. So that means that all of those marked angles, along with the green ones, are all exactly the same measure. Now the other two angles have to be congruent because the angles that are marked are congruent. The third angles theorem says that the remaining angles have to be congruent to each other. And since those are alternate interior angles, we're going to see for C that we can say that BC and AD are actually parallel. So again, solve the diagram and then answer the questions. So congruent to DAB, we have angle A, angle ABD, angle BDC, and angle C. Congruent to ADB, though, we just have angle DBC. And what can we conclude about AD and BC? They must be parallel because ADB and DBC are a pair of alternate interior angles. So the converse of the theorem says that if alternate interior angles are congruent, then the line